let's say I've got some type of a book over here. So there is my book. I'll write it down, book. Let me draw the entire book. So this is my entire book just like that. And then I have a mirror over here. So this is a mirror. We're just looking at the mirror from the side. I can do a better job of a straight line than that. So that is a mirror. Now what I want to do is pick, and I'm really picking an arbitrary point on this book. And we know that there's light being shown on, there's light that is coming on this book. Maybe, I haven't told us about the light source, but we're assuming that the book will reflect the light diffusely, like most books do. It is not a shiny book. And so any point on this book, and we could pick any arbitrary point on this book, is going to be emitting light in a whole bunch of directions. So what I'm just going to do is pick 2 light rays that are being emitted from this point on the book. It'll be more than 2, but this will help us understand what's going on here. So let me pick one light ray that goes like this. It's obviously not curving like that. So it goes like this and hits the mirror. Incident angle is equal to reflected angle. So it will reflect off at the same angle, just like that. And let me pick another point that is coming out radially from that same, or another ray that is coming out radially from that same point. So it'll come out like that. It will come out like that. It has a larger incident angle, so it'll have a larger reflected angle, just like that. And now let's think about what an observer, someone who has their eyeball right over here. So let's say someone has their eyeball right over here. So let's think about what this person, let me draw their eyebrows so you get the general idea. Let's think about what this person right over here will actually see. Now, their eye, and remember, all of reality is really just a big simulation going on in our brains. Now, this person's eye is going to see these 2 light rays diverging from some common point. If you were to look straight at the book, or let me just do another example. If someone were to just look at any arbitrary object, let's say let's say that's an orange right over there. And just ignore all of this stuff on the left. If I were to look at an orange, no mirror, nothing, no reflections or anything, if I were to look at a certain point on the orange, light from that point would be diverging out radially. And if my eye were right over there, my brain says, okay, I have these light rays diverging from a single point. It will simulate, or it will show me that point on an orange in my brain. Now, the same thing is going to happen here, even though the light, these 2 rays actually aren't diverging from a point out here. Your brain will say, okay, I got 2 things that are coming out from what looks like a point over here. It'll really just extrapolate these lines backwards. So it'll take that green ray and it'll say, okay, it must be coming from a point out there. And it'll take that magenta ray and they'll say it must be coming from a point out there. Whenever, even here, your eye is just seeing these 2 light rays. It doesn't know what's going on over here. It just says, okay, they're just converging from a point. And so in this person's reality, or in my reality, I think that there is an orange there. Likewise, I see these 2 light rays diverging from some common point. I will extrapolate to figure out, or my brain will try to think about where that point is in 3-dimensional space. It says, look, these 2 rays look like they're coming from a point back over here. Now, the reality is there is no back over here. That's just that there is nothing. We're not assuming there's nothing behind the mirror, but to this observer, it looks like the light is being emitted behind the observer. And so what the person would actually see is something like this. The person would actually see something like this. And this is probably not too foreign to any of our experiences. We've all looked in mirrors. And remember, this is the left side of this book. This is the right side of the book. It's the side that has the curvy part of the B. So it's the side that has the curvy part of the B. So it'll look like this. So what this observer sees is an image that looks like this. It is what people call the mirror image. It is flipped. The left and the right is flipped, and you can think about why that is. I could just draw another ray right here to make it clear. If this ray is coming like this, now it will reflect and come out back like this. To this observer, it came from that point right over there. So he sees a flipped version of the book. Now, the whole reason why I did this is, one, just to make you feel a little comfortable with these reflecting lines and all of that. But one, I guess more importantly, to get you more comfortable with the idea of a virtual image. This right here is a virtual image, and we're going to compare it with a real image in the next video. And to some degree, a virtual image is more intuitive because we have so much experience with it when we think about mirrors or reflected surfaces. So it's a virtual image. And we call it a virtual image because the book really isn't there. It's virtually there. There is no actual physical space, or we don't know if there's any physical space behind the image. Our brain just uses these diverging lights and creates a model inside of our brain or whatever to say, okay, that book exists there, even though the source of the light is over here. Now I'm just going to draw another diagram, and this is more, you normally won't have the diagrams that have more this type of perspective, but just to give you a sense of the same thing, and just to get you familiar with some of these diagrams we're going to do when we study mirrors and lenses, is we could imagine that, let's say that this is the ground. Let's say that this is a mirror, and let's say that this is actually could be somebody standing in front of a mirror. Although usually people will draw an arrow here to just say an arbitrary object. Well, let's just say we have an arrow in front of the mirror, just so you get used to this notation. This is actually a physical arrow. This is not a light ray. Now, let's think about what the image of this arrow. Let's say this arrow had eyes, so it's actually a person. So it's this arrow had eyes. What would this arrow see? Well, let's just pick an arbitrary point on this arrow. You could do it with any point, or this object, because every point will be reflecting light diffusely. So I'm going to take one point that's coming straight out of the mirror, one light ray that goes straight to the mirror. So just parallel to the ground, straight to the mirror. Well, it's just going to reflect straight off and then come back. It's just going to go straight off and then come back to the source of that light, maybe that arrow's eye, if you view it as a person. And let's just do another point, another ray coming from that point. So another ray coming from that point might come out like that. Incident angle is equal to reflected angle, so then it would come back like that. Now, maybe this whole thing is an eye. Maybe that'll simplify things. Maybe this, let me make it, so let's say this whole thing is, you're looking really close at a mirror. You're looking really close at a mirror. This whole thing is an eye. Now, what would the eye see? Well, this ray looks like it's coming from back over here. And then this ray looks like it's coming from back over here. This is where they converge. So the eye would see this point of the eye over there. So it will actually see itself. It will actually see itself. And in general, these type of diagrams are used to think about what would the real or virtual image be of an object once the light from that object goes either is reflected off of a mirror or goes through some type of lens. And we'll be doing this a lot more in future videos. But anyway, hopefully that gets you a little bit familiar with the things we'll be dealing with.